Hello, young scientists! Remember in your Class 7 studies when we learned about the movement of objects? You might recall thinking about how to tell which object is moving faster, right? Well, the secret lies in the distance an object covers in a certain time. That's what we call speed or velocity. But here's a question to ponder. Have you noticed how a rolling ball slows down or sometimes changes its direction? What could make that happen? In everyday life, when you kick a football or throw a ball, you apply a force, which is simply a push or a pull that changes how the ball moves. Forces are everywhere when a hockey player flicks the ball with a stick, or a goalkeeper dives to stop the ball. Forces act, causing changes in motion. Think about it like these forces are like invisible hands that move objects in different ways. They can make things speed up, slow down, or turn around. On this journey, we'll explore what forces are and how they affect objects around us. Pause for 20 seconds and think. What everyday activities involve forces changing motion? Can you come up with 3 examples right now? Great thinking. All those examples involve forces in action. From riding your bicycle to opening a door, forces play a key role. Let's dive deeper into the fascinating world of forces. Let's look at Figure 8.1 displayed on your screen to understand how forces work in sports. Notice in the first illustration, the goalkeeper stretches out to stop a soccer ball heading towards the goal. This is an amazing example of using force to stop a moving object, which is done by pushing the ball away or catching it. In the second picture, a hockey player is flicking the ball using a stick. Here, the player applies a quick upward force, which can change the ball's direction and speed. Isn't it fascinating how a simple flick alters the ball's path? The third illustration shows a cricket fielder crouching down to stop a cricket ball. The fielder applies force by catching or blocking the ball to prevent it from moving further. These actions are examples of forces being applied as pushes or pulls. The goalkeeper pushes or catches, the hockey player flicks, a push, and the fielder pulls or stops the ball. Think about other sports you enjoy. Can you identify when you push or pull something like a ball, bat, or racket? Take 15 seconds to think about it now. Wonderful. These everyday actions are all about forces. Understanding these examples helps us see how forces change motion in the real world. Now that we've seen forces in action, let's explore exactly what force means. You may notice when you push a door open, or pull a drawer, or flick a ball, you're applying a force. But what is force scientifically? Force is defined as a push or a pull acting on an object. This interaction causes the object's state of motion to change. For example, if a ball is at rest, applying a force can make it start moving. If it's moving, force can make it slow down, speed up, or change its direction. Imagine you're playing with a toy car. If you gently push it, it rolls forward. The push is the force that makes it move. If you pull it back, again force is working, but in the opposite direction. This tells us forces can act in different directions. Pause and think. Can forces act without touching the object? Hint. Think about magnets or gravity. Excellent question. Science tells us some forces, like magnetic force or gravitational force, can act at a distance without physical contact. These fascinating forces also affect motion. We will explore them shortly. For now, remember, force is what changes how objects move. Always a push or a pull. Let's dive into a hands-on activity called Activity 8.1. On your screen, you can see Table 8.1 from our textbook showing various daily life situations. Your task is to identify if the action shown involves a push, a pull, or both. For example, look at row 1 about moving a book on a table. You can push the book away or pull it closer. Hence, both push and pull apply here. This is a great way to recognize forces around you. Going through each situation, such as opening a door, drawing water from a well, or kicking a football, think carefully. Is the force applied a push, a pull, or could it be both? Try to fill in the table with your answers. Remember, pushing moves things away, pulling brings them closer. Take a moment and think about the action of drawing water from a well. Would you classify the force as push or pull? Pause for 15 seconds. I hope you marked it correctly as a pull, because when you draw water, you pull the bucket upwards using a rope. This activity helps us understand how fundamental push and pull forces are in our everyday lives. After exploring push and pull forces, you might wonder, are these the only types of forces? Actually, in science, forces are divided into contact and non-contact forces. Push and pull forces are contact forces, meaning you need to touch or physically interact with the object to apply the force, like pushing a door or pulling a drawer. But have you ever learned about magnets? Did you know that a magnet can pull a piece of iron without even touching it? This is a special kind of force called magnetic force, which is a non-contact force. Similarly, gravity is a non-contact force that pulls objects towards the earth without any physical contact. Think about when you drop a ball, it falls because Earth's gravity pulls it downwards. Pause for 20 seconds and reflect. How do you think forces like magnetism or gravity affect the motion of objects differently from push and pull? Great thought. Non-contact forces can act from a distance and often cause attraction or repulsion, influencing motion without direct touch. This makes the study of forces even more exciting. Taking another look at Figure 8.1, let's focus on how forces affect motion. When a football player kicks the ball, the force speeds the ball up. The ball moves faster now compared to when it was at rest. When the goalkeeper stretches and catches or pushes the ball away, the force applied slows down or stops the ball. Here, the force acts opposite to the ball's motion. Similarly, the hockey player's flick changes the direction of the ball. The force isn't just speeding it, it's redirecting it towards a new path. Imagine yourself playing these sports. Applying force is like having control over how fast, slow, or where the ball moves. This connection makes physics practical and fun. Let's pause for a moment and think, if no force acts on a moving ball, what do you think will happen to its motion? Pause for 20 seconds. Great thinking. According to physics, if no force acts, a moving ball would keep moving at the same speed and in the same direction forever. It's forces that cause changes in motion. Let's take a moment to review what we've covered about force. We learned that a force is essentially a push or a pull applied to an object. This simple idea explains many actions we see every day. Whether you are pushing a swing, pulling a drawer, flicking a ball, or lifting your school bag. All these are forces in action. Forces can be applied through contact, like these examples, or at a distance, as with magnets and gravity. Importantly, forces control how objects move. They can speed things up, slow them down, or change their directions, just like in sports or even in nature. Now, to get your mind working, here's a question. Imagine you are pushing a heavy box and suddenly stop applying the force. What will happen to the box's motion? Think for 15 seconds. Excellent. Without the force, the box will gradually stop moving due to friction, a force opposing motion. It reminds us that multiple forces often act together in the real world. Our study on forces continues to uncover all these interesting interactions. Let's focus on where a goalkeeper is saving a goal. In football, the player kicks the ball using force applied by the foot. The stronger the kick, the faster the ball moves. This force has both magnitude, how much, and direction, which way. The goalkeeper anticipates and applies force with their hands or body to stop the ball's progress, either by catching or pushing it away. This is an example of force causing a change in motion here, slowing or stopping the ball. Think of playing your favorite game. The way you apply force determines your success. Kicking gently may not reach the goal, but a powerful, well-directed kick can score. This shows how science and skill work hand in hand. Pause and reflect. What happens if the goalkeeper misses applying force? How would the ball's motion change? Think for 20 seconds. You're absolutely right. Without force applied by the goalkeeper, nothing would stop the ball, and it would continue into the goal. Force is the key player in the game. Now, let's walk through Activity 8.1 step by step. Look at the table displayed on your screen from our textbook, Table 8.1. Step 1. Begin by reading each scenario carefully. For example, moving a book on a table involves pushing or pulling. Step 2. Identify the action involved. Is it pushing, pulling, lifting, or others? Step 3. Decide if this action is a push or a pull, or possibly both. Mark your answers in the table accordingly. Step 4. After completing the table, discuss your observations with friends or your teacher to understand different viewpoints. By doing this activity, you develop a keen eye for spotting forces in everyday life, making science relatable and fun. Pause for 15 seconds as you visualize this process. What other examples can you think of that might fit into this activity? Amazing! Your curiosity will help you uncover many scientific wonders. Let's talk about a fascinating force you might have seen in action: magnetic force. Unlike push and pull forces we apply by touching objects, magnetism works at a distance. Magnets have poles called north and south. Opposite poles attract each other, pulling together. Similar poles repel, pushing each other apart. This push or pull happens without the magnets actually touching. Try this next time. Bring a magnet close to iron objects like nails. You'll see the objects get pulled towards the magnet, a clear example of magnetic force acting without contact. Pause and imagine. What would happen if Earth itself was a giant magnet? Think about how compasses work to find directions. Magnetic forces are crucial not just in science labs, but also in everyday technology like motors, speakers, and even MRI machines in hospitals. It shows how science discoveries make our lives better. Let's review. Forces are invisible helpers that change how objects move. Whether you push a swing, pull a rope, or watch a magnet attract metal, forces are at work. From sports fields to everyday chores, and from the natural world to advanced machines, understanding forces helps us appreciate science in action. Forces can speed things up, slow them down, stop them, or make them turn in different directions. Think about the last time you rode a bicycle. Pedaling applies force to move forward, brakes apply force to slow down. This simple idea connects physics to your daily life. Pause and reflect. How can knowing about forces make you a better athlete, engineer, or problem solver? Take 20 seconds to think. Fantastic. Science empowers you to see the world differently and master your environment. Keep questioning, exploring, and discovering. Did you know that every day you use forces many times without realizing? Opening doors, turning taps, pushing chairs, or kicking a ball all involve forces. In fact, farmers pulling carts or workers lifting loads use force to get their tasks done. Even something as simple as pumping water involves applying a pull force. Understanding these forces helps us to do tasks safely and efficiently. For example, using the right amount of force can prevent injuries or save energy. Try to observe and think about the forces you use today. How can you use force smartly to do things better? Pause for 15 seconds and reflect on your daily routine. Excellent! Your awareness of forces already starts shaping your scientific thinking. Forces are not just limited to sports or household activities, they operate on huge scales in nature too. Gravity, a force you experience every day, holds planets in orbit around the sun and keeps us firmly on the ground. Wind blowing across the land and ocean currents moving water are caused by forces acting on air and water molecules. Even walking, running, and jumping rely on forces exerted by your muscles, pushing and pulling your bones. Thinking like a scientist, these forces explain the beautiful movements and balance in nature, from the tiniest insect to the largest mammal. Pause and imagine. How different would life be if forces stopped working? Nature depends on forces to function properly. Understanding this brings us closer to the wonders of science. As we close our exploration today, remember that forces are powerful yet often invisible influences shaping everything we do and see. Whether pushing a swing, pulling a drawer, or feeling Earth's gravity, forces are at play. We have learned to identify forces as pushes or pulls and understood their effects starting movement, stopping it, changing speed or direction. We also saw that some forces act without touch, like magnetism and gravity. This knowledge forms a cornerstone of physics and unlocks many doors to advanced topics. Now, let me leave you with a thought. Imagine you could control forces like a superhero. What inventions or discoveries would you create? Keep that curiosity alive as you journey through science. Thank you for being such enthusiastic learners today. Keep exploring, questioning, and discovering the magic of forces.